I want to talk briefly about using alternative methods to determine energy consumption from runtime data and what kind of load would be good to do that kind of measurement on. This is actually this is our compressor here at the onset facility, and we put an AC current CT on one of the feeds going to it, and we use the UX90-006M to do that. And I just wanted to show you what the resultant data would look like and why runtime may make more sense for this particular application. Again, in order to get this CT on here, we had to get into the control panel. Certainly this is 240, so we probably should have monitored both of those leads, two CTs on there to get the total. But again, because it's what's called a constant load variable time, or fixed load, if you will, it would be a good candidate for runtime monitoring. So I already went to file and open data file, so let's plot the data. So there's our data, and we can see from this we're logging at a 10-second logging interval. Again, if you're trying to capture this kind of information, you need to be logging pretty quickly. Again, if we had a power meter on here, that would be one thing, but unfortunately we didn't have one on there because we didn't want to get in and hook up voltage leads and get an electrician involved. So what you can see here is basically it's drawing approximately 12 amps, between 12 and 13 amps when it's on, 0 when it's off. You'll notice there's a few spikes in here. Let me select my zoom tool and we can zoom around it. And what we're catching is we're actually catching and again, because this is not a triggered logger, we don't have the ability to start logging as soon as we see a spike. So it's logging at a fixed 10-second interval. So it's catching, it looks like a surge or an inductive kick or something when it's first firing up, but it's only catching it randomly. It's not catching it every time. So, but for the most part, you can see that, we'll go back to the full scale, is we have a fixed load or a constant load. All we have is a varying runtime. Again, here we go. You can see how it comes on for a little while, and it's off, it's on, it's off. So a runtime logger, a runtime measurement would make a lot more sense for this type of application, because, and again, if you could do you could put a clamp on meter on this load when it's running to figure out what the energy consumption or power consumption, depending on what you're interested in. Most of the applications I've seen, people are looking for power, and then they calculate energy from that. But either way, you could, when it's running, you could put your clamp on there to figure out what it's running, and then just figure out the runtime. Let me show you how you would do that using one of our runtime loggers. Before I do that, just one other note about this kind of data. We do have customers who export this data to Excel. HOBOware doesn't have any way to calculate runtime from this analog type data, but we have customers who they'll write a formula in Excel, export this data to Excel, and do it there. And they get an idea of what their runtime is. You have to be careful with that. You may not be catching all the on-off cycles depending on what your logging interval is set to. We've opened a data file from a motor on-off logger, and I want to show you how that data is presented. So we did a file, open data file. This is our plot setup screen. Here, when we configured the device, we configured it for runtime. So by default, when you see this, and again, it really depends on how you have your preferences set in HOBOware. If you have it set to show plot all series, all of these will be checked off by default. I don't have that turned on, so you'll see there's only one, and it's labeled in black, the motor percent on. But HOBOware also has the ability to calculate percent time off, and then also the time on and off within each logging interval. So I want to see those as well. One of the internal events that's plotted is calibration. The motor on off logger gives you the ability to calibrate the logger, or basically educate the logger as to what an on motor or a running motor looks like. And if you look at our UX90 course, our training course that's online, it will show you a little video about how to do that. But you basically press and hold the calibrate button while the motor's running, and it will educate the logger and tell the logger this is what a running motor looks like. And again, it has two AC fields. It doesn't need any external sensors. If you have access to the motor winding and it's an AC motor, or a motor housing I should say, and it's an AC motor, you can just put it on the side with no external sensors and it'll pick up that field. So let's plot this data. So here's our data, and you can see internal calibration was logged. It gives you the time and date when it was calibrated, and it actually flags it here too in the data set. So there it is right there. Tells us when we actually calibrated the device. And here is our runtime data. So we had a 5-minute logging interval set. You can see it from the data table. If you wanted to confirm that, you can click in what we call the details pane and click on deployment information. Scroll down through and it will tell you what your logging interval is set to. If you set this up, the logger up for state logging, which is the other mode that this logger supports, there is no logging interval. It's just scanning once a second. When you set a logging interval, when you're using runtime, it's still scanning at once a second. However, it is so you basically get down to a 1-second resolution within your logging interval as to changes between on and off states. So that being said, here in our first 5-minute interval, we can see that the motor was running 66% of the time, 34% of the time it was off. Or to do it another way, here's your the amount of time it ran within that 5-minute interval, 3 minutes and 18 seconds, and it was off for 1 minute and 42 seconds. So this gives you a very convenient way to calculate what your total runtime is over the length of your deployment. You can do that using a filter here in HOBOware. This is the free version of HOBOware. If you click on time, so select the series, time on, and then go to the filter icon here, or edit and filter series, and select total time on in a specific time period. Obviously, well, maybe not so obviously, but you want to make sure that your total time on interval is greater than your logging interval. So let's say, and again, this was a very short deployment, so I will say total time on in every hour. Click on OK, and here it totalizes it up per hour. So it ran for 20 minutes, basically from 2 o'clock to 2:40, and from 1 o'clock to 2 o'clock it was 3 minutes, which we don't have a complete data set, so we don't have 2 full hours, but it gives you an idea of how it calculates that. You can also export this to Excel and do it there if you wish. Once you have your total runtimes calculated, either by hour or by day or whatever you might need, then you can simply export this file or this column of data to Excel and multiply these times either the energy that you measured previously or the power consumption, and get your actual power consumption based on runtime only and that spot check. To export only this column, you can just go to File, Export Table Data, and then in your export window, just select Total Motor and click Export, and it will be exported in the format that you set in your preferences, and then you can apply that calculation in there and get your energy consumption that way. This other example of runtime is monitoring an electric hot water heater. We didn't want to we knew that it was a single element and it was just would come on for a certain period of time and then go off. So we put what we call a CSV-A8, that current switch device, and a UX90-001 time of use logger configured for runtime. And I want to show you that data here. So here's my data for my deployment. over a few days. So what we have here is a 1 hour logging interval. Again, keep in mind the UX90 is scanning at a 1 second rate, so it's looking for a change of state to a 1 second resolution. But we're logging the run times once an hour. So what we're seeing is that these are the percentage of times in each hour how much that hot water heater is turned on, how much it's turned off. And then we actually have the actual time per hour that it's on and the actual amount of time per hour that it's off. So put a meter on there, you put a clamp on Fluke or some other type of energy meter, figure out how much energy it uses, and then multiply all of these on times or add these all up and then multiply them times that number, and you will have the energy consumption for the length of this deployment. And again, HoboWare gives you that information. If you click on series statistics, it'll tell you how many samples it took. 62 samples, again at a 1 hour interval, at 62 hours it was recording. So you would know that from October 19th to October 22nd, from 6:23 or basically 6:24 p.m. to 7:24 a.m. on that day, I used X amount of energy on my hot water heater.